Today, we're going to build a digital fortress. We're talking about something called a virtual private cloud, or VPC. Now, I know, it sounds a little technical, but trust me, understanding this is one of the most important things you can do to keep your stuff safe online. So, let's get into it. Just imagine, this alert lands in your inbox. Your stomach just hits the floor, right? Your company's most important data, the production database, is just sitting out there, completely exposed. And this isn't some made-up story. This kind of nightmare happens all the time. The threat is very, very real.
And this number? This is the scale of that threat. In the real alert that inspired this, that's how many times someone tried and failed to log into that database in just 1 hour. 47,000. Think about that. That's more than 13 login attempts every single second. It's a constant, automated attack against anything you leave unprotected.
So how on earth does this happen? Well, the scary part is, it's not usually because of some brilliant hacker. It happens because this is the default. This is the danger you're in from the moment you start unless you actively do something to protect yourself.
Here's a good way to think about it. When you just spin up a server in the cloud, it's like building a house in the middle of a huge public city square, and then just not putting any locks on the doors or windows. Anyone walking by can just stroll right in and try to open things.
So how do we fix it? How do we build the walls and lock the doors? Well, that's exactly where the virtual private cloud comes in. It's not just some extra feature. It's the foundation of your entire security setup. It's how you build your fortress.
Okay, so there's the official textbook definition. But what does it really mean? It means you get to carve out your own private, completely isolated slice of the public cloud. It's a network that belongs only to you, and more importantly, you make all the rules. This slide really shows the difference, doesn't it? Look at the left. It's a straight shot, a superhighway from the chaos of the internet right to your server. But on the right with a VPC, that's much better. We have layers. We have a firewall, a public area, and then a secure private area where the really important stuff like our database lives. Now, I know all this talk about subnets and firewalls can feel a bit abstract. So to make this all really click and be easy to remember, we're going to use a simple analogy for the rest of this explainer, an office building.
So yeah, from now on, whenever you hear VPC, I just want you to picture your own private office building. You own it, you decide who gets in, and you control the keys to every single room inside. Let's break down the analogy. The building itself, the whole structure, that's your VPC. The different floors inside, those are your subnets, separate areas for different teams or tasks. The main entrance from the street, that's your internet gateway. And the keys to each individual office, those are your security groups. Now this is maybe the most important part of our building, the different floors. Think of a public subnet as your building's lobby. It's meant for visitors. This is where your website server lives. But a private subnet, that's the secure back office. The internet cannot get in there directly. This is where your databases belong. You wouldn't put the company's safe in the lobby, right? Same idea here. Okay, so we've got our building, we've got our floors, but how do we actually control who goes where? Well, there are 2 layers of security here, and it's really important to know the difference. We have security for the whole floor, and then we have keys for each individual room. So, a security group is like the key to an individual office room. It's very specific. A Network ACL, or NACL, is more like the security guard standing at the elevator for the entire floor. And a really big difference is that the room key is stateful. It remembers you. The security guard is stateless. He checks your ID every single time you get on or off the elevator. Let's dig into that stateful idea for a second, because it's actually pretty smart. It means the security group has a memory. If your server inside the room makes a call out to the internet, the security group remembers it. When the answer comes back, it's just automatically let in. It's like a bouncer who remembers you, so he lets you back in without any hassle. Network ACLs, on the other hand, are stateless, no memory. They're like that super strict security guard. If your server wants to get data from the internet, you need one rule to let the request go out, and a totally separate rule to let the response come back in. Every packet, every time, in both directions, gets checked. All right, now that we know how to build the fortress, let's talk about all the ways people accidentally knock it down. We're going to cover the most common, most dangerous mistakes people make. And honestly, if you can just avoid these, you are way ahead of the game.
And here it is, mistake number 1. The big one. Putting your database in a public subnet is the digital version of putting your company's most secret files in a glass display case right in the middle of your public lobby. You're just inviting trouble.
So the fix is simple, and I want you to burn this into your brain. Databases always, always, always go in a private subnet. The only thing that should ever be able to talk to it is your own application server. That's it. This isn't negotiable.
Now, this little line of code might look innocent, but it is a total security disaster. That 0.0.0.0/0 part literally means the entire internet. And when you apply that to all ports, you've basically just left every door, every window, every single possible entry point to your building completely unlocked for anyone to try.
The fix is a really important security concept called the principle of least privilege. It just means don't give anyone any access they don't absolutely need. Does the public need to see your website? Yep. So open ports 80 and 443. Do they need to log into your server's command line? Absolutely not. You lock that down so only you can get in.
So let's boil it all down. Building a secure VPC really comes down to these 3 steps. 1. Isolate. Keep your public lobby separate from your private back office. 2. Lock your doors. Use very specific security rules. Don't just leave things wide open. And 3. Build for resilience. Don't have your whole business in just one building. Spread it out so if one has a problem, the others are still running.
And that really brings us to the final thought. Your VPC is your first and most critical line of defense. We've just walked through the blueprint on how to build it right, so the only question left is, have you checked the locks on your own front door lately?